So we've looked at some differences between pure substances and impure substances, so pure things like elements and compounds, and then mixtures, which are impure. This next little section is if you have a mixture that might be impure, how would you get them separated? How would you get the mixture apart? So there's a number of different techniques you got to look at. There's actually 7 in your notes, which looks like quite a lot, though don't be worried about that because lots of them are very kind of common sense, junior school kind of little techniques. In terms of what you need to get from this, it'd be being able to pick out the right technique for a particular scenario. So they might give you a mixture in the exam and ask you to pick from a list or maybe write down an answer. Which technique would you use to separate this out? You could maybe have to do a diagram of a particular technique. You could maybe have to do a short explanation about how you would do it practically. I'll try and guide you through that. The first separation technique would be if you had a mixture of an insoluble solid and a liquid. So a more easy to understand example would be maybe if you had a mixture of sand and water. As you know, sand doesn't really dissolve, otherwise we'd have no beaches. So how would we get water and sand separated from each other? So here's my mixture in here. So this is my, for example, my sand and water. So a sludgy mixture in the speaker. I would use filter paper in a filter funnel, and that would get the sand trapped in the filter and the water be able to go through. So a couple of technical terms. So the sand is here because it's the insoluble solid. We refer to the thing left in the filter as the residue. The water has gone through the filter pretty easily, and we would call it the filtrate in more general terms. One we think about the diagram there, just to focus in on it, it's not particularly clear in the computerized diagram printed out here. If you're asked to draw it, be really careful that you show the filter paper. So this is how we might draw the filter funnel. The filter paper you draw is a wee V shape within that filter funnel with your residue on top of it, and then a wee conical flask down below to catch your filtrate. Just make sure you show the filter paper when you're being asked to draw that. Second separating technique is evaporation. So slightly different scenario. We've now got a mixture of a solid and a liquid, but the solid's able to dissolve in the liquid, so it's now a solution. If I wanted to get the solid back from that solution, I'd have to use evaporation. So separating a solute means it's dissolved from a solution. In this particular one, it's actually important to focus on the point. I'm trying to get the solute back. I'm not very interested about the liquid or the solvent because I'm just going to evaporate and let it go out into the atmosphere. There's another technique which is different to that we'll look at in a second, but in this particular one, I'm not interested in keeping the solvent or keeping the liquid. It can go off and I'm not too fussed about losing it. Okay, so in this case, I literally would take my solution, I would put it on top of a Bunsen burner on top of a gauze and a tripod, heat it, the solvent will evaporate and we'll leave the solid behind in the evaporating dish. One wee thing to focus in just in drawing the diagram, the gauze is sort of drawn in there. That's one way of drawing it. So if I have like a tripod, you can do it as a series of X's over the top of the tripod. And that's absolutely fine. If you prefer though, you can do wee dashed lines. That's another acceptable way of drawing a gauze. So either or, pick your favourite. Now this third one, it's given its own kind of subcategory. It's not actually a really different separating technique. It's called crystallization. It's pretty much the same as this. So it's the same idea. You've got a mixture of a solid dissolved in a liquid to make a solution. You want the solid back. There's a slight problem with this technique of evaporation is that when you're heating something really strongly, it often goes a wee bit too quickly and the solids start to spit out at the end and you get like a really fine, messy powder once you finish that. If you still want your solid back, but you want it as nice kind of full, proper crystals, you should use crystallization, which is basically just like a wee bit of a more careful way of doing that evaporation process. So to separate a dissolved solid from a solvent, so same scenario, the solution is heated for a short time. This creates a saturated solution. The difference here is that you don't heat it until it's completely dry. You actually will leave it once it's kind of saturated or once it's kind of really concentrated. A saturated solution is one in which no more solid can dissolve at that temperature. Once you cool that down though, you will see the solid start to sort of drop out. You might know that yourself if you've got like a hot tea and you have got lots of sugar in it. Once that tea cools down, you might find the sugars settle down at the bottom. If you do that though and do it really slowly and carefully, you actually will form crystals rather than a powder, which you might want. So that's called crystallization. You do a bit more slowly, a bit more carefully, let it cool down rather than heating it till it's dry. Gives you crystals at the end. Fourth one is a wee bit different, the separating funnel. So this is, we've not got two solids in this case, or sorry, a solid and liquid in this case. We've got a mixture of two liquids. Now, in this case, it's not that hard to separate liquids because in this scenario, we'd be separating immiscible liquids. The word immiscible means doesn't mix, so liquids that do not mix. That might sound a wee bit confusing, though a very common example of that would be oil and water. If you're really bored, you can go down to your kitchen and check that. If you add a wee bit of tap water to a wee bit of cooking oil, you will find that they will not mix together. One will sit on top of each other. They'll form two different layers. So we might have a scenario where we want to separate oil and water from each other. It's not that tricky. Essentially, they're already sat in two different layers. You just need to pour out the layers separately and then they'll be separate. We have to kind of do it nice and carefully though, so they don't mix up and they kind of keep a nice two settled layers. The piece of apparatus we use to do that is called a separating funnel, which you might not have seen in school. If you can imagine a burette, which we have used, so that big long tube with a tap at the end, but a version where it's all kind of like in a big container, so it's not like a long narrow tube, it's like a large kind of container which holds a lot of liquid. If you pour your oil and water in there, again you see by the shading here, you've got two separate layers. What you can do quite easily is open the tap very gently and this bottom layer will drain out. You'll close the tap just before it gets to the top layer because you don't want them to be impure or mixed together. You would get a different beaker. One we think can be tricky, you might be thinking, well, how do I kind of cope with the bit in the middle, which is kind of like the mixture of the two? If you want to be really careful, you can actually get another beaker and kind of completely get rid of that bit in the middle where it's kind of very close to being the two different liquids, and sort of get rid of that kind of tricky bit in the middle where you're kind of going from one to the other. Once you got rid of that, you can get a third beaker and then separate out and empty your second layer. So if you're being really careful, you'd empty the first layer first, stop before you get to the bit in the interchange, the layer between them. Get a second beaker, get rid of that messy bit in the middle where it's quite hard to stop it in time before you get from one to the other. Close your tap again, get a third beaker and drain out the top layer, and that'll get you two beakers of pure separated liquids. Now, final three methods. First one is simple distillation. This would be a scenario where, a bit like this, where we had like a soluble solid dissolved in a solution, so like salt and water. But this is a different technique we'd use for a different kind of purpose. When I evaporated, I wasn't too interested in where the solvent was going. I just wanted to get rid of it. I might have a scenario where I do want to keep the solvent or the liquid. For example, if I was on a desert island and I need some water, I would get some seawater, which is salty, so I can't drink it. I want to evaporate the water to get separated, but I don't want to lose it. I want to keep the water that's been evaporated. If I want to do that, I use a technique called distillation. And this diagram is on the top of the next page. I'll show you here. So this simple distillation is essentially two processes together. It involves evaporation because I needed to get rid of the solvent, but I then condense the solvent back down to turn it back into liquid. So if I talk you through this diagram, here is my mixture, so it might just be a mixture of salt dissolved in water. I then heat it. When I heat it, the salt's going to stay behind because it can't really boil that easily, but my liquid, my water here, is going to evaporate and going to boil away. Now, if it was just evaporation, I would just go off into the atmosphere, but it's trapped in this apparatus here. The only place it can go is down this side of it, because that's closed off by the thermometer. The thermometer is just there to kind of check the temperature of the gas that's being given off. If this was water, that should be reading 100 degrees C because that's the temperature of steam. So it's just a wee check you can do there. One wee side point on that, if you're asked to draw this or maybe spot a mistake in the apparatus, you should have the thermometer bottom at that point at the top of this apparatus. So in other words, the point where it's just about to go in the condenser, you should put the bottom of the thermometer there. Anyway, so you've got your steam or your vapour going through. It's not very useful to me as a gas or a steam, so I want to turn back into liquid. So it goes through this piece of apparatus called the condenser to turn back into liquid, which we'll gather at the bottom here. To turn a gas back into liquid, you need to cool it back down. So the condenser does that, it cools this gas down. How it works is it's kind of like an open tube, so the gas still goes through there and turns back into liquid, but there's a little jacket around the outside of this condenser. In this jacket you can flow water through it from the tap, so cold water can go around the outside of this tube and out the other side, so you've got a constant supply of cold water kind of surrounding this condenser. Because it's quite cold, that will, when your gas hits the side of the wall of this tube, will cool down and turn back into liquid. One important thing about the condenser though is just make sure you got your labels the right way. You're meant to put the water in at the bottom to make it coldest at the bottom and sort of warmest at the top, and it should come out the top there at the end. So it's a little bit confusing. Just very concisely one more time. In distillation, you heat up your liquid, your solution, your water will evaporate. It will feed into the condenser where we want to turn it back into a liquid. We turn it back into a liquid by cooling it. How we cool it down is we surround it by cold water. So we put water in around the outside of this condenser, and so whenever the gas goes through, it's going to hit a cold surface, cool back down, turn into liquid, and drip out into my container. All of that is mentioned in the notes at the top. So step 1 is boiling, step 2 it turns into cold condenser and condenses, step 3 is collected. One wee term just to know about, the special term we'd use to talk about the liquid we collect at the end is we call that the distillate. A little bit like filtrate we have in filtration. At the end of distillation we have a distillate. Almost there, so on to technique 6. This is fractional distillation. It's not very much different from normal distillation. This is using a slightly different scenario. So normal distillation, we were trying to get a solvent back from a mixture of a solid and a liquid. So if I had salty water, I want the water away from the salt. We would use fractional distillation if I'm trying to get two liquids apart. So you might be thinking, hold on, we've already done two liquids. We used a separating film for that. That was when we had two liquids that didn't mix with each other, so form two layers, which is quite easy to separate. You can get mixtures of liquids which do mix together. A common example of that would be a mixture of ethanol and water. Ethanol is just the fancy scientific name for alcohol. So things like alcoholic drinks are obviously a mixture of some alcohol and some water together. They're not in two different layers, it's all mixed together. So some liquids do mix, which makes it a wee bit trickier to separate them. So what I do to separate them is I do distillation with them. And if you think about it, how that works is different liquids will have different boiling points. So if we look down here, the boiling point of ethanol is 78 degrees C, the boiling point of water is 100 degrees C. So if I heat it up, I should get the ethanol boiling first and going through my distillation apparatus, and I should get the water boiling second and going through. So I should be able to use two different beakers to separate them at two different times to collect the different liquids. You might think, well, why is this different technique? Because the technique could just use this same apparatus up here. The one slight snag with using what we call simple distillation with two liquids is because the boiling points aren't that different, if you tried it with this apparatus, you actually probably get the water and the ethanol boiling at the same time. They've got pretty similar boiling points, it's quite hard to control when they actually will come across. The way we solve that is we use a slightly different piece of apparatus in fractional distillation, which what this is called a fractionating column. It's basically a big long tube which has got kind of like glass beads or glass kind of sticky out bits going through it. The only purpose of that is it makes it harder for a gas to get from the bottom to the top where it's going to condense again. If I make it harder for gases to get to the top of the apparatus, it separates them out a wee bit more. Essentially, the harder you make it for something to move through a particular piece of apparatus, the more spread out you'll be if you're putting two different substances through it. If you had a race between different people and it was just a race along a flat horizontal surface, probably everyone would do it in a similar time. However, if you make a race up a mountain, that's obviously much more tricky, a much more arduous journey, so therefore you probably get better separation. So the harder you make it for two different substances to move through something, the more they'll spread out. Beyond that is just simple. It is the same as simple distillation. You're going to evaporate your two different substances at different times. At various points, the ethanol will come across first and condense. I would change my beaker then because I can check the temperature when that's all been moved across. And then I would get the water coming across second. I therefore would get two different distillates there. I would get the ethanol distillate first and the water distillate second. Each different distillate I get, we would call a fraction. So I'd say I have the ethanol fraction and then I have the water fraction.